We are going to be doing notes about slope. Let's talk about what slope is first. So slope is what describes the steepness of a line. Think of a ski slope. You could have the bunny slope, which is a little bit more flat. You could have like, I think it's called the black slope or something. It's super, super steep. That is the slope, which describes the steepness. We're going to be doing this from multiple representations, from a graph, from an equation, from a table, from 2 points. The only representation that is missing here is from a word problem, which we will get into at a later date. So let's start with from a graph. First, you're going to choose 2 points on the graph. So for instance, I might choose this one and maybe this one, and you would be making a table of those 2 points. You're going to count the rise from 1 point to the next, and then the run. We're going to do this a little bit different than you did in junior high. So in junior high, you would actually count the spaces. The problem is our graphs in algebra don't typically count by ones like this one. So it's better when we're counting this rise and run to use our points, and I'll show you what that looks like. Then you're going to be writing the slope as change in y over change in x. So let's start with our points. This point here, the 6 is on the y-axis. So when we write our point down, we're going to put the 6 in the y-axis. And then the other place would be 0. Everybody always gets these mixed up. So I try to focus on what axis the number is on, and then that's the spot I put it in. So our first point is 0, 6. Our next point, the x is 4, and the y is -6. So we have 4, -6. When you count the rise, what you're essentially doing is not counting spaces, you're counting the difference between the 2 spaces. Well, difference in math is subtraction. So here's our y's. I'm going to find the difference between these 2 spaces, between the -6 and the 6. So what I'm going to do is put my -6 in parentheses and subtract my 6. This is how you find the difference. Well, -6 minus 6 is -12. Then I'm going to find the difference between my x's, between the 0 and the 4. So I'm going to take my 4, subtract 0, and I get 4. The last step is always to reduce. -12 divided by 4 is -3. So this would be the slope of this line, otherwise known as -3 over 1. This is how you write it as change in y over change in x. So on B, I'm going to do it again. I'm going to find 2 points. So let's go with, let's not pick one on the axis, just in case we're not great at knowing where to put the 0 and where to put the number. So I'll pick that one and that one. Sometimes people struggle with picking points because they're not quite sure what we mean by that, especially if the points aren't given to you. So to describe that, I always say look for the crosshairs on the grid. So like here's a crosshair, here's a crosshair, here's a crosshair. Well, here's a crosshair that's on the line. So we can pick that point. I wouldn't pick this point, this right here, because it's not on the crosshair. So try to pick something there. Then I'm going to make a table of my points. So let's start with this one. The x is -4, and the y is -4. So I've got -4, -4. On this one, my x is 4, and my y is 8. So go ahead and write it in our table. Now, instead of counting the spaces, because if I counted the spaces, it would be 1, 2, 3, 4, 5, 6. And then people always ask, do I put negative or +6? So instead of doing that, let's find the difference, which is the same thing as counting, between the 2 y values. So I'm going to take my 8 and I'm going to subtract my -4. which would give me 12. Then I'm going to find the difference between my x values. So I'm going to take my 4, subtract my -4, and that would give me 8. It's really important that you reduce. Both of these, the 4 goes into. So 12 divided by 4 is 3. 8 divided by 4 is 2. So my rise over my run is 3/2. You'll also be asked to do these finding slope from an equation. Well, in order to find slope from an equation, the equation has to be in slope-intercept form. And that looks like y equals mx plus b. This is the very first form that you learned about. Slope is the coefficient, oh, I can't spell today, in front of x. Oh, I guess we have in front right here. It's the coefficient on x. So oftentimes when we have junior high kids come in, they'll tell us it's the x. Your slope is the x. Well, the problem is x is a number we don't know. The number that's in front is a completely different number. It's not x. Technically, it's which is how we represent slope in slope-intercept form. So once again, the slope is not the x. It's the coefficient in front of the x. So here I find my x, look at the coefficient, that's my slope. It only works if the equation is in mx plus b. So here I do have a plus b, but technically it's plus 0. So here my slope would be 15. Here my slope would be -0.1 or -1/10. It's very important that you understand that it's only the number in front of the x if it's in this form. If I had more numbers over here on the left, then I would have to fix that. And we'll go into that at another time, but in this form, pretty simple. From a table, you're going to find the rate of change. So from a table, it's called rate of change. From a graph and an equation, it's called slope, but they're the same idea. It's still the rise over the run. You're going to write the change as change in y over change in x. Now, I personally do not like tables written horizontally, so I'll typically turn these around to where they're vertical. So I've got -1, 0, 0, 2, 1, 4, 2, 6. I think this is just easier for the brain to understand. And then you're going to do the same thing that we've done from a graph, because this is the same idea. You've got points on a graph. Here you've got points in a table. So I'm going to find the difference or the space between the y's by subtracting. And then I'm going to find the difference or the space between the x's by subtracting. And if I'm correct, it'll be the same on the next one. So I could do 4 minus 2 or 6 minus 4. Let's do 6 minus 4. That also equals 2. And then 2 minus 1, which also equals 1. So as long as it's constant, it's the same every time, then this is linear. And that means you can find the slope. So looking at B, let's count the spaces between the y's, also known as finding the difference. I'll write a little note right here. And then count the spaces between the x's, also known as the difference. So this would be -4, this would be 3, so this would be my slope. If I check another one, it should be the same. If it's not, then if we were to plot these, it wouldn't make a straight line. Sure enough, we are good to go. The last method is from 2 points. Well, if you're consistent and you do this method where you find the difference this way on a graph and then you find the difference this way on a table, then it's not going to be any different from 2 points. The only thing here that you'll have to add is labeling your x and your y coordinates. And then you're going to find the change in y and the change in x using the slope formula, which essentially we've been using. You take your second y, subtract your first. You take your second x, subtract your first. I love tables. I think tables are much easier to look at. So I just take these points, throw them into a table, and then we're back to the exact same procedure. Find the difference between your y's, and then find the difference between your x's, and then simplify. 4 goes into both of these, so this would be 3 over 1 or 3. We just like to write it as change in y over change in x. On B, I'm going to go ahead and write it in a table and just find it easier. Now, I'm going to take the difference between my y's, and then I'm going to take the difference between my x's. Again, easier in a table, easier to look at. You're consistent. You don't have to remember too many steps. It's just the same ones over and over again if you use a table every time. Negative 14. Ooh, interesting. The only thing I would say about this is you've got 2 negatives. Well, fractions are also considered division. And if you think about division with 2 negatives, you have a rule to remember. So you've got a negative divided by a negative, which equals a positive. You can do the same thing here. Love me a good table. Love tables. Find the difference between your y's. And remember, difference just means subtract. Find the difference between your x's. Ooh, negative 15. And then reduce. 3 goes into both of these. 6 divided by 3 is 2. Negative 15 divided by 3 is negative 5.